And now we are finally on question 11, the last question for this paper. We have 11.1 saying events A and B are mutually exclusive. It is given that probability of B is 2 times the probability of A. And then the probability of A or B is 0.57, and we have to calculate the probability of B. So use what they told you. They told you that probability of A and B are mutually exclusive. When events are mutually exclusive, this is a diagram of mutually exclusive events. So a way that I help my students to remember this is we look at mutually exclusive like this. So we're looking at event A and B. If events are mutually exclusive, then it means that these events have mutually agreed to exclude each other. So you can see there is no intersection in this case. So because there's no intersection, that's the whole point of mutually exclusive events. Mutually exclusive events, the probability of A and the probability of B would be equal to 0. We don't have an intersection. And that's a big part of this. So they also tell us, look at the other information they tell us. Apart from telling us the probability of B is 2 probability of A, they also tell us about the probability of A or B. So when we are putting these probabilities together, so let's see how we would add them. We know that the probability of A or B is going to be equal to the probability of A plus the probability of B minus the intersection, right? But in this case, we know the intersection is 0. So you don't even have to include that. We can just remove that. So you can't say minus 0 and show them that, or you could even remove it. It's fine. They would know that, okay, this is mutually exclusive events. So now we know the probability of A or B, that is 0.57. So 0.57 is equal to the probability of A. They don't tell us anything about that. They only tell us what the probability of B is, but they put it in terms of the probability of A. So we can just say probability of A, leave it like that, then plus the probability of B. That is 2 times the probability of A. So we're saying plus 2 times the probability of A. So you can see that this is a case where they are making the probability of A the variable that you have to find. Okay, so that is like saying 1 probability of A plus 2 probability of A. That will be equal to 3 times the probability of A. And that's 0.57 that we have. Then we just have to solve for the probability of A by dividing both sides of the equation by 3. And so 0.757 divided by 3 would give you that. So I'm just going to put it in decimal form. It means therefore that the probability of A is equal to 0.19. Okay, so that's the probability of A. But let's also just not forget what they specifically asked for. They specifically asked for calculate the probability of B. So now we know what the probability of A is. We can find the probability of B because they told us the probability of B is 2 times the probability of A. So just say probability of B is equal to 2 times probability of A. We know what that is. That is now 0.19. Okay, so we're just substituting that in that place, in probability of A's place. So that will finally give us, so just say 0.38. So that is the final answer that they are asking for. Okay, so 11.2 says, a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. Okay, so then 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. So 11.2.1, they say, what is the probability that the first calculator chosen is not defective? Okay, so the way this information is being put, this is clearly a tree diagram that we're going to need to draw, because you can see that there's 2 selections going on. First time a calculator is selected, then the second time a calculator is selected. But in this case, remember they say that it is not replaced after the first one is selected. So in total, there are 40 calculators. Then we know that 5 of the calculators are defective. So let's put down a tree diagram. We're going to have calculators, and there'll be ones that would be defective. I just call it defective, and the ones that are not defective, not defective. So there are a total of 40 calculators. I need to move this down because it's not going to be space for the other part. Okay, so we know now the amount of calculators that are defective. They told us 5 of the calculators are defective. So there are 5 calculators that are defective out of a total of 40 calculators that we have. And then the calculators that are not defective would be minus 5 of that. So it's going to be 35 out of 40 calculators that would not be defective. Okay, so this one would represent the probability of the first pick. The first time somebody reaches in and picks out a calculator, they can either get a defective calculator or a not defective. The first time when nothing has been picked yet, the chance of picking a defective calculator would be 5 out of 40. The chance of picking not defective would be 35 out of 40. Then in the second pick, now this is where we look at that. If they picked a defective calculator, what happens? So again, we're going to look at the probability of defective calculators and not defective calculators. If they picked out a defective calculator, then it would mean that there's now one less defective calculator, meaning there is 4. The chances of them picking out a defective calculator would be 4 out of not 40 calculators anymore, but 39 calculators in total. So this would be the chance of picking out a defective calculator. Then, again, if they chose a defective calculator, what is the probability that they would pick out a not defective calculator? The not defective ones were not touched. Only the defective one was touched the first time, was picked out. So it means that there are still 35 not defective calculators, but out of a total of 39 because one defective calculator has been picked out. Then we'll also look at the second part. Again, we're looking at the defective calculators and the non-defective calculators. So if you picked out a non-defective calculator, what is the chance that you're going to pick out a defective calculator the second time you pick? So we would have to look at it like this. The non-defective one has been picked, meaning the defective ones are not being affected. Okay, so remember this part, okay, represents the second pick. So we're just saying if the first pick was actually a non-defective calculator instead, then it means that the defective calculators that would still be there would still be the total of 5. Because this time we didn't pick out a defective. So it's still 5 defective calculators, but a calculator has been picked out already. It's a non-defective one. So there's still 39 now calculators left. Then the last one, what is the probability that we're going to get a non-defective calculator if you picked a non-defective calculator the first time? So there'll be one less of it. So instead of 35, there's now going to be 34 non-defective calculators out of a total of 39 calculators. Okay, so that's what the tree diagram looks like. So let's just look at what exactly they are asking for. They said, what is the probability that the first calculator chosen, so probability that the first calculator chosen is not defective? The position matters a lot. They're saying in this one, the first calculator chosen needs to be not defective. They are not bothered about what the second calculator chosen is going to be. So when we're looking at this is what they're saying. The first calculator just has to be not defective. So if we're looking at the first pick and the second pick, first calculator and second calculator that's been picked, we just want this one to be not defective. The second one can be anything. So the second one can either be defective or it could be the case of it was not defective. As long as the first one chosen is not defective. So these are the two cases you need to look at. It's not just one case. So it doesn't matter what the second one is. So this is what we're going to be looking at. These two, we're going to be looking at a case of when in the first try, we pick a non-defective calculator, and then in the second one, multiply by the second try a defective calculator. So from that, you see now that what we have is probability of the first one being not defective would be, we would first have the not defective, which was this, the 35 over 40, multiplied by this 5 over 39. So that's the first case we could have. Or we could have the case of this. And remember, when you say or, it's really to add. Because if I say, what is the probability of getting heads or tails, then it means I can get either heads or tails. It's still fine. So you have to include the probability of heads and also the probability of tails. So we need to add. So we're saying plus what this one will give us. So we're looking at, first of all, we need to pick a not defective calculator in this first pick. And then in the second pick, we should also pick a not defective calculator. So you need to first define these things and see what are all the things they're talking about first. What are all the situations they are talking about first? So we're adding that to this being not defective, which is 35 over 40, multiplied by your not defective here, which is 34 over 39. Okay, so you can put these in brackets if you want. And then let's see what that gives us. And when we put that all in, it actually just gives you 7 over 8 as your answer. So you can put this number as a decimal. You can also put it as a percentage, but it's also fine like this. Okay, so that is the answer of the first one. Okay, then the next question, 11.2.2, they say, what is the probability that if two calculators are selected? Okay, of two calculators, of course, will be selected. But then, okay, they're saying one calculator is defective and the other is not. Okay, so let's think about what all of this would mean. One calculator has to be defective and the other has to be not. So no matter how they are being picked, you just need to make sure you have one defective and one not defective. Look at all the things we need to include now in this. So let me erase all of this first. So we're still looking at the first and the second picks, or the first and second calculators that have been selected. One is defective, one is not. It can be in any order. They didn't specify. If they said the first must be defective and the second must be not, then you're going to have to take defective first, then not defective second. And then that would be all. Okay, you just multiply them like that. But they just said one calculator has to be defective, the other must not be defective. So we can take this in any order. So we have to take both situations. We have to take where the first one is defective and the second one is not defective. Or it could be the situation of the first one being not defective and the second one being defective. So you have to take these both cases because they were not specific. This would be before under this criteria where one calculator is defective and the other is not. Okay, so let's just find those, and then because we have all, we add them together. So we're looking for defective first. So defective 5 over 40, and we're going to times that by, so that was the defective one, 5 over 40, and then multiplied by the not defective in the second pick. And not defective in the second pick would be this one. So that would be the 35 over 39. So multiply by 35 over 39. Then that probability, we're also going to add it to the second case. So that was just the first case. Okay, and then the second case, so after this, the second case is we have to take a not defective, and that would be the 35 over 40 multiplied by a defective one in the second pick. So in the second pick, we have to take a defective. That will be 5 over 39. So that's what that looks like. Okay, so can you just go ahead and simplify that and see what we get? Okay, and the answer we get is, as a fraction, is 35 over 156. So you can put this as a decimal if you want. You can also put it as a percentage. It would be accepted. Okay, so that is 11.2.2. And then we have 11.2.3, and this says, what is the probability that if two calculators are selected, both are defective? Okay, so two calculators, of course, are going to be selected, but now this time, both need to be defective. So we're actually just looking for here the probability of defective and defective. That's what we're looking for. So that is only one case. It's not two things that we have to consider. It can only happen once. So defective and defective will happen over here. The first one is defective, and the second one, the second pick, is also defective. So those two, just multiplying those two together, and we'll work with that instead. So that's a 5 over 40 times 4 over 39. And as a fraction, I just get 1 over 78. Okay, so that's the answer for that one. And now we move on to 11.3. So 11.3 says 4 different economics books and 3 different life sciences books are required to be placed on a shelf. Okay, so 11.3.1, if you decide to place any book in any position, in how many different ways can you arrange the books on the shelf? So we are not grouping the books, we're just putting them in any way. Remember, you basically have to just see how many books do we have. We have economics book, so 4 books are economics books, 3 books are life science. So in this case, we're not grouping them or anything. We just have to find out how many books are there. There will be 7 books in total. So to find out how many ways we can put them on the shelf, you can see it like this. The first book will have 7 places that it's allowed to sit in, because it can either sit in the first position, second, third, all the way to 7. So that's 7. Then multiply by, once the first book has been placed, wherever it's been placed, the second book has 6 more positions to be placed, because the first book has already been placed down. So the second book has 6 available spots to sit in. So that's times 6. Third book has 5 available spots. The fourth book, 4 available spots. The third book, 3 available spots. Then 2 available spots and 1. So that is really just 7 factorial, which will give you, which will be equal to 5,040. So these are 5,040 ways that you can arrange these books on the shelf. Okay, so that is the first one. Then the second one says, if 2 particular books must be placed next to each other, in how many different ways can you arrange the books on the shelf? Okay, so now there's a grouping happening here. They don't tell us which 2 specific books, but we know that 2 books are going to be grouped together. So I'm going to put it like this. This is 2 books being grouped together. Remember, we have 7 books in total. So the other 5 books are just going to be put here. So there's your other 5 books just being put there as well. Okay, so since now we have to just find out how many different ways they can be arranged. This is how we look at this. First of all, you're going to take these 2 books and you're trying to see how many ways can they be put as they are as a group, because they need to be next to each other. So here's your first book, here's your second book. You can either put it in this arrangement where the first one is first and the second one is second. So that's 1. And then you can also put it where the second one is first and the first one is second. So there's 2 total ways that these 2 books can be arranged where they currently are. So that's 2 factorial. That's what we just call that. Now let's look at the other books. The other books, we can pretend that they're being grouped, but not together, alone. Like this one book is a group on its own. That one is a group on its own. That's alone, and that's alone. There's a reason I'm calling them just groups for a reason. Okay, so if you look at each of it, it's really just how many ways can this one group sitting here be arranged? Just 1 factorial. Then multiply by how many ways can this one group be sitting on its own? Just 1 factorial. And this is what I'm going to do here. So multiply by 1 factorial for each book. And then, because all the books need to be allowed to move around everywhere, they cannot just sit like this. For example, this book can be sitting here instead. And this book can be sitting here instead, or even here. They should still be able to move around. This is what we can do. We're looking at it as if they were groups. And now we just have to count how many groups have been formed by this. It's really this being your first group, that's your second group, third, fourth, fifth, and sixth. So now there are 6 groups being formed, and you need these books to be able to move around anywhere as well. So we'd multiply that by 6 factorial, so that your groups are allowed to move around. So it's kind of like your books are now allowed to move around. Putting this together was so that these 2 stay together and they are allowed to move around, as in first book and the second book, or it could be a case of the second book and the first book. But when we say times 6 factorial, we're basically giving all of these books the right to be placed anywhere. So this as a group can now even sit in between these 2 groups, or in between those 2 groups, or even all the way at the end. So that's why we multiply by 6 factorial. We kind of look at each of these as if they were individual books. But then we have to say 2 factorial here because these 2 books don't always have to sit as 1 and 2. They can sit as 2 and 1. Okay, so if you look at this and you just simplify this, what this actually says is 2 factorial. And then if you multiply all of these 1 factorials, they're just going to give you 1 no matter what. So it's really 2 factorial multiplied by 6 factorial. And that will give you 1,440 ways. Okay, and then we are on to the last question. And then the last question, 11.3.3 says, if all the economics books must be placed next to one another and all the life sciences books must be placed next to one another, in how many different ways can you arrange the books on the shelf? So again, this is a case of grouping the books. We're placing them next to each other. If you use the same principle in the previous question, this will work out. So think about it like this. We're looking at the economics books. So eco, we have 4 economics books over here. Then we have life science. So LS, we have life science. Let me just put that in blue. So 3 life science textbooks over here. And what we're going to do is we're creating a group. We're creating a group for economics and for life science. So this is one group. This is another group. And what we're going to do is, for this to be able to move around in any way, we're looking into the first group. We have 1, 2, 3, 4 books in there. These 4 books should be allowed to sit in any arrangement. It doesn't have to sit as 1, 2, 3, 4. It can be 2, 1, 3, 4. And all the other ways. Now, the total ways that these books in the economics section can be seated or can be placed on the shelf, that would be the 4 factorial. That's just for this one group here. Then for the life science, for this group, the way these books can be seated, it's like you still have the first book, second book, and the third book here. There are 3 books, so we can say multiply by. They should also be allowed to sit in any way as they are inside this group. So that is going to be multiplied by 3 factorial. Okay, because it can be the first book, the second book, and the third book. Then it can be a case of the second book first, then the first book, and then the third book, and so on. So it will be 3 factorial ways that they can be seated in total. But then, so that the books can all move around freely, as in it doesn't have to be economics seated here, all of them packed together here, and then life science, all of them packed together here. So that doesn't happen, we look at how many groups have been created. We created only 2 groups. It's this, the economics, and the life science. So then we multiply that by 2 factorial, so that we're looking at the group seating like this. These books can either be placed on the shelf as first your group of economics textbooks, then your life science, or it could be put in the case of first the life science, then the economics. That's where the 2 factorial is coming from. Okay, so that will give you your answer. So let's go ahead and see what that gives. And here there are 288 ways that they can be seated. So it's always good to first create the groups that they spoke about. Like here as well, I also created groups. So they only grouped these 2 together, and then the rest were just on their own. But I pretended each book was an individual group. Okay, so that is a method that you can use to calculate this. So that is the last question. The answer is just 288 ways. And that's it for this video.